Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. Here you can find other interesting subjects as well along with the engineering drawing. Do subscribe the channel to get alerts. If you like this lecture, please hit the like button. Now, let's see the plane surfaces, especially the square plane when it's making angle with both the planes, that is HP and VP. Now, let's take a plane, a square ABCD of some length, edges, resting on one of its edges, say AD in HP, its surface making some angle with HP, and this edge, which is in HP, AD, is making an angle with VP also. Let us see how to do. So here, this is the plane surface, right? And it's making surface making some angle with HP, and one edge, say this edge, is making angle with the VP also. Let's see how to draw these projections. Now, let's take the reference line. And here, the square is constructed, ABCD. Of course, while drawing the projections, we take only the edges. So, we take show the dimensioning. And here, we have taken or took care, the care should be taken here while drawing the top view. The top view is drawn first here in the square is drawn here because its surface is making an angle with the HP. That is the first thing. That means the plane should be either parallel to HP or in HP. It should be taken in HP because it is resting on something in the horizontal plane, that is AD. So AD, this edge must be initially perpendicular to VP. That's why AD is taken perpendicular to VP and its projections are drawn. Now, the plane should be taken in the horizontal plane having one edge perpendicular to VP. Now draw its projectors. And the front view should be drawn here, A, B, C, D. A, B, when you are seeing in the front, A, B are nearer to the observer. CD are away from the observer and they should be kept in the brackets. Now, next, its surface is making an angle some 30 degrees with HP. So, draw a line here at 30 degrees angle and mark the same length here on this line. And this same front view is redrawn in the new position, that is at 30 degrees angle. Mark the same points here, A, B, C, D. Right? Same, everything is same. Now, draw its projectors from all the points. So from A, B, C, D, we have drawn the projectors. Now, from these points, from the first position, you draw horizontal lines. The intersection points are marked here. That is from A dash here and A. This is marked as A, B, C, D. The top view points are marked here. Join these points by straight lines. So A, B, C, D, the points are marked. Now this AD edge is making an angle 30 degrees to VP. Now this edge is AD is making 90 degrees angle with that means it is perpendicular to VP. Now we want this edge at 30 degrees angle. So here we can take, we are at liberty, we can take the edge AD making 30 degrees angle either this side like this or here this way 30 degrees. It is up to you because no other condition is given whether this BC edge is other edge. BC is nearer to the observer or nearer to VP. That's why you can take. So here let's take this side. That is, we have drawn a line here at a 30 degrees angle, and on this we have to mark the same AD edge. The AD which you are seeing in the top view is the true length because you see this point in the front view, it is a point. That means it is perpendicular to VP or in HP or parallel to, even if it is parallel to HP, in the top view we see the true length. So we want to show this angle here for this edge AD, that is making 30 degrees angle to the reference line or VP. Now on this, we have to mark AD. So take one point here and mark it as A. Take the same, mark the same distance here and mark another point and call it as a D. Now AD is marked. Once you get 2 points, you can get other remaining points, whatever may be the number of points. So from AB, you mark the length, and from A, draw an arc, right? And similarly, mark DB length. There is no edge at all. Mark this length, DB. From D, draw another arc here, intersecting this earlier one at a point. This intersection point is nothing but B. Now, similarly, AC edge is AC length is marked. From A, draw another one arc. DC length. From D, draw another arc. D as center. Draw another arc, mark it as C. So join all these, we got all the points. That means we want to just reproduce the same figure here. So draw these points A, B, C, D by straight lines. That means we have just reproduced the figure here in a different position. That's all. Top view is same, absolutely. There is no difference at all. Now, that means we have just rotated the plane like this in the clockwise direction. Now you see AD is here. Now from these points, draw projectors. Okay, from all the points. And from this previous point position, draw horizontal lines from all the points. So all the points are drawn here. Now mark these intersection points. So corresponding points from A and A dash here, right? Mark A dash because this is the front view. A dash, B dash, from B and B dash here. This is B dash. Likewise, mark all the points, intersection points, and join them by straight lines like this. So that is the final front view. So these are the final projections of the plane when it is making angle with both the reference planes, HP as well as VP. Now, next, let's take another plane, say square lamina ABCD. It's resting on BC here, right? It's a surface making some 40 degrees angle with HP, and the same BC is making an angle 45 degrees with VP. Let us see how it is. So let's take the reference line, and the surface is making 40 degrees angle with HP. So here it is 40 degrees, and this is edge is BC edge is making 45 degrees with VP. So at 45 degrees we draw another line, and these are the final projections of the square plane. Now let's draw this is the actual, we are seeing the surface, how it looks like, how the actual plane looks like. But we are going to draw the projections, that is by taking the edges only. So here we are going to represent that. Take the reference line. Draw the square in the top view. How? First, you have to look for the surface angle. The surface is making angle with the HP, some angle. So take the plane either parallel to HP or in HP. That is the first condition. Second one, it is resting on HP, something, whatever it is. That means something is there in the HP. So take the plane in the horizontal plane, right? So here, if you observe, take the plane in the horizontal plane. Now, BC is making in HP. The edge, some edge, plane edges BC is in HP. That's why we take one edge. This edge is resting in the horizontal plane. Next, AD and BC. That means actually, if you observe this is one edge. We may call it as AD, and suppose if this will be automatically BC. AD and BC both are making 45 degrees angle with VP. That means this edge as well as this edge, both are making 45 degrees angles. Because both are parallel, both will be making 45 degrees. So this is the position of the plane. And finally, if you see, the plane appears like this. Now let's draw the projections. So by taking BC is A plane is in HP. Okay. First draw the top view so that you take the square in the top view, mark the dimensions, mark the points here, A, B, C, D, draw projectors from all the points and mark the front view. It is taken on the horizontal plane. Now, that is one condition satisfied. Next, it's a surface making angle with 40 with the HP. That too, we can actually, to get the surface angle, we can lift this BC upwards or AD upwards. But it is resting on BC. That's why we have to rotate, we have to lift AD only upwards. So lift AD upwards, like this. So this is the plane taken at a 40 degrees angle. Now this is ABCD. Okay, all the same points are marked here, same length, but at a different position, 40 degrees angle. This is the surface angle with the HP. Now, draw projectors from all these points, right? And draw horizontal lines from these points here. Mark the intersection points as A, B, C, D. We get 4 points. Join them by straight lines. We get a rectangle here because it's a surface is making an angle with the HP in the top view. It appears like a rectangle. Now, this edge, which is actually in the horizontal plane, BC, opposite to this we have AD. AD and BC both are making 45 degrees angle with the BP. So we draw a line here at 45 degrees angle. On this, we take this one edge, right? Either AD or BC. AD you take, because both these two lines are parallel. If you show one, either BC or AD, automatically the second one also will be at the same angle. So AD is taken here. Already we have seen, mark one point first and name it. Get the distance of a second point and mark it here and name it. These are the reference points from which we can draw all the remaining points. So once you get these points, we get all the other points. Already we have seen, and we are going to repeat the same thing for all this type of problems. So you just concentrate on this one and AB, mark AB length. From A as center, draw an arc with AB as radius. Next, DB as radius, DB as distance, that DB as radius, D as center, draw another arc intersecting at B. That's how we get point B. Like this, we can get any number of points like this. We get C. So we got all the points here. Join them by straight lines. We get the reproduction of the same figure here. We just reproduced in a different position. Okay, here it's angle is 90 degrees. Now we have taken at 45 degrees angle. That's only the difference. So that same top view is reproduced. From this, you draw the projectors. Okay, all the projectors are drawn here. And now mark all the horizontal lines from these points are marked. And now mark these intersection points A, B, C, D. So you get A, from A, this is A dash. So this intersection point will be A dash. Because this is the front view, this is named as A dash. So similarly, D here, D, B, likewise all the points. Join them by straight lines. We get the front view. So these are the final projections of the square lamina ABCD when its surface is making angle with both the planes. Now, let's take another one. ABCD, same ABCD, 50 mm edges, resting on the corner now. Earlier it was on the edge. It's resting on corner. Its surface is making an angle 40 with the HP and the diameter. Here some other reference is given. Let us see how to get it. So here, because we want the corner in HP, corner is taken on either left side or right side. Of course, in this case, because of even number of corners, we got corners on both left side as well as right side. Now this will be the first position. Second position, this 40 degrees angle with the HP, surface inclination. Next, this diagonal, right? The other diagonal is BD. That BD is making 45 degrees angle with the VP. So these are the final projections of the plane surface, plane lamina. Okay, we are able to see the plane here, right? Two-dimensional object. But we are going to draw the projections by taking only the edges here. Now let's see how to draw it. So we have to take the first plane in the horizontal plane because it is resting on HP, and because its surface is making angle with HP, we have to take the plane in the horizontal plane only. So let's draw the square here, ABCD. By taking one corner, you have to get one corner on this side, either left side or right side. And here to draw this, you take this edge or this edge. They will be making equal inclinations. So say 45 in this case. So draw a line here at 45 degrees angle and draw the square on that line, and get the square. Okay. Once you have drawn it, show the dimensions, draw projectors from all these points, and show the front view. Already we have seen all these positions earlier. So take the front view of this. Now its surface is making 40 degrees angle with HP. And which corner? A. Here on the left side A, on the right side C. We have corners. So you can lift either left side or right side, right? Any side. But here we want A in HP. That's why you have to lift only on the right side here like this. So draw a line here at 40 degrees angle and reproduce the same front view. The same points are marked. Now let's draw the top view, projectors from front view here, and draw horizontal lines, mark the intersection points, join them by straight lines. You get the top view when its surface is making angle with HP. Now we want the diameter BD. Here if you see AC and BD are diagonals, right? It's not diameter, it's a diagonal. So the diagonal BD is this diagonal AC is making an angle with HP. Okay, but this diagonal BD is here. This BD is parallel to VP. Sorry, it's parallel to HP. It's parallel to HP. So it's a parallel to HP means it's a true inclination, that is 90 degrees is visible in the top view. When it is parallel to VP, its actual inclination can be seen in the top view. So let's take this BD line here at a 45 degrees angle to VP. Draw a line here at 45 degrees angle, and now you show this angle here. Okay, this 45 degrees, this BD is taken on this line. Because it is parallel to HP, the inclination which you are seeing in the top view is true inclination. So we have marked BD. From this reference, these two reference points, we can get A and C also like this. A and C. Get the other points. Join them by straight lines. We get the top view. That means same top view is obtained here, is redrawn in a different position. That is, if you just rotate this clockwise, B this side, you get this figure, same figure. Okay, so same top view is reproduced. Next, draw projectors from all these points here, right? And draw horizontal lines from all these points. You get the intersection points here, right? Mark them, A, B, C, D. Join them by straight lines, and you get the final front view. So like this, we are able to draw the final projections of its surface when it's making angle with both the planes. Okay, so by saying this, how do you say that this surface is making angle with both the planes? Yes, it's one question need to be asked. Here, in the front view or in the top view, suppose if you are able to see its actual shape, then we can say that its surface is parallel to that plane. If its a true shape is seen in the top view, the plane is parallel to HB. If it is seen in the same square is seen in the front view here, it will be parallel to the VP. But here in none of these projections, we are able to see its true shape. That's why it is making angle with both the planes. Clear? So, hope you had understood this topic very well. If you have any questions or any comments, please do write in the comments, like, share, and subscribe. Thank you.